All right, today we are going to look at adding and subtracting polynomials. So this should build on some of your prior knowledge with combining like terms, dealing with algebraic equations. So I'm hopeful that today's lesson will be pretty smooth sailing for everybody. Again, today the gold notes are uploaded on Google Classroom. So as you're going through this edpuzzle, you don't need to worry about scrambling and taking down the notes. It's all provided for you in Google Classroom. So you take your time and write down the notes. It's your choice. If you want to take those notes now before you go through the video, or you can do it afterwards. Whatever works for you. Okay, Marco was given this problem, 3x squared plus 5x squared. And when he added it, he got 8x to the fourth. There's a thumbs down is telling us that Marco made a mistake. Can you tell me what is his mistake, and can you correct the answer here? Marco made the classic mistake. He did not combine like terms, right? So 3x squared plus 5x squared are like terms. We just add the coefficients and keep the x squared. So he should have got 8x squared. He may have been confusing when you do multiplication, right? X squared times x squared is x to the fourth power. But this was addition. Let's look at the next one. Kamaya has 2x minus parentheses 4x plus 5 and works down to negative 2x plus 5. Again, thumbs down. Kamaya made some type of mistake. Can you figure out the mistake and what is the correct answer? Kamaya made the classic mistake. Classic. The distributive property forgot to distribute the negative 1 to the 5. So it should have been 2x minus 4x minus 5. And then our final answer for this would have been negative 2x minus 5. So we have a binomial here, and the lead coefficient is negative 2. Alexis has a beast of a problem here. She's adding a trinomial and a binomial. So she has 4x squared minus 2x minus 5, and then she's adding the binomial 3x squared plus 7. Again, this has a thumbs down. Alexis made some type of mistake. Can you figure out the mistake? What would be the correct final answer? Alexis' mistake was when she combined the negative 5 and the 7, she put minus, and then she put positive 5 plus 7 there. She should have actually said plus, and then in the parentheses, she should have had negative 5 with 7. Don't really like her process and how she did things. We'll be talking about this today as we go through the lesson, how I'd like you to show it. Ideally rewriting everything using addition. So we'll talk about that into lesson today, but the answer should have been 7x squared minus 2x plus 2. Adding polynomials. To add polynomial expressions, we simply remove any parentheses and combine like terms by adding their coefficients. Like terms are two or more monomials that differ only by their coefficients. So first little example here, 3x plus 4y plus 7x plus 11z. Our like terms are the 3x and the 7x. And so then when we combine those, we'll end up with the expression 10x plus 4y plus 11z. Next little example here, we have 3 parentheses 5x squared plus 6x plus 7. And then outside the parentheses, plus 5x plus 2. So the first thing we have to do is use distributive property to remove the parentheses. So when we do that, we get the 15x squared plus 18x plus 21. That's simply 3 times 5x squared, 3 times 6x, 3 times 7. And then don't forget, we still have the 5x and the 4, which we didn't multiply those because they weren't inside the parentheses. And then we would combine the like terms. So our like terms in this example now is we have the 18x and the 5x, and we have the 21 and the 4. So when we combine those, we end up with 15x squared plus 23x plus 25. Let's work through an example of adding polynomials when they have parentheses. So we have 6x squared plus 3x plus 4 plus 2 times the quantity 4x squared plus 7x plus 11. All right, so first thing to do, remove the parentheses. What do you think we're going to do here? On the left side, do we have to change anything? No, we're distributing a 1, right? So that's going to be the same. And then on this polynomial on the right here, since it's 2 times that, we're going to multiply each term or each monomial by 2. So let's see what happens when we do that. We get 6x squared plus 3x plus 4, and then it's plus 8x squared plus 14x plus 22. Do you see how we multiplied the second polynomial by 2? All right, our next step is we're going to combine like terms, and we're going to write the result in standard form we learned yesterday, which is from the highest exponent to the lowest exponent, or the constant, if it has a constant. All right, so let's do that. And we get 14x squared. I have it all color-coded for you here so you can see the like terms easily. So 6x squared and 8x squared gave us the 14x squared. 3x plus 14x gave us the 17x. And then 4 plus 22 gave us the 26. And there it is in standard form. This is an example of a trinomial. The lead coefficient is 14. The degree of the polynomial is 2, this is going to be a quadratic trinomial, which we'll be doing a lot with here moving forward in this class. I would like you to rewrite this polynomial without the parentheses. When you type it in, remember, use the caret key to show an exponent. So when you go x caret 2 for the x squareds, the caret key is the shift 6 key on your keyboard. All right, so in this example, it was pretty simple. We just removed the parentheses. There's nothing for us to do. Everything was addition. So we have 18x squared plus 7x plus 9 plus 6x squared plus 2x plus 5. Now, I would like you to combine like terms and write the result in standard form. Did you get 24x squared plus 9x plus 14? Again, we have a trinomial. The lead coefficient is 24, and the degree is 2. Rewrite this expression without parentheses. So we have the 2x squared plus 4x plus 7 plus 3 times x squared plus 2x plus 4. So I want you to rewrite it without parentheses. So now we have 2x squared plus 4x plus 7 plus 3x squared plus 6x plus 12. I want you now to combine like terms and write the result in standard form. I hope you ended up with 5x squared plus 10x plus 19. 2x squared plus 3x squared is 5x squared. 4x plus 6x is 10x. 7 plus 12 is 19. All right. Oh, here's a challenging one. I'd like you to rewrite this without parentheses. This one you needed to do distributive property twice. So the first polynomial, 3x squared plus x plus 2, we multiplied everything by 2. So that's how we get 6x squared plus 2x plus 4. The second polynomial, x squared plus 2x plus 4, we multiplied that one by 3. So that's how we got the 3x squared plus 6x plus 12. Now I want you to do the next step. I want you to combine like terms and write the answer in standard form. So the answer for this one is 9x squared plus 8x plus 16. Our lead coefficient for this example is 9. All right, let's move on to subtracting polynomials. To subtract polynomial expressions, we simply change subtraction to addition by adding the opposite. So in our example here, we have 9x plus 40y minus 7x minus 13y. We can rewrite that as 9x plus 40y plus negative 7x plus negative 13y. And I put the parentheses around those so that you don't have a plus minus sign right next to each other. You want to break those up so you're showing that you're adding a negative term. So then we would combine like terms, and we'd end up getting, in this example, 2x plus 27y. Next example here, we have 14x squared plus 30x minus 15. And then we're going to subtract the trinomial 4x squared minus 3x minus 2. So you can still think about this as add the opposite. We remove the parentheses for the first term. And then the second one, we remove the parentheses, but we have to have opposite signs. So the 4x squared becomes negative 4x squared. Minus 3x becomes plus 3x. Minus 2 becomes plus 2. Another way I think of this is you're distributing negative 1. So the first set of parentheses, we distributed positive 1. And then after the subtraction sign here, we're distributing, it's like distributing negative 1. So we end up getting 14x squared plus 30x plus 15 plus a negative 4x squared plus a negative 3x plus negative 2. Wait a minute, I think I made a mistake here. Let's see here. This would be positive 3x. That should not be a negative sign. That should be positive 3x. Let's fix this right now. Okay, I cleaned up my mistake here. So negative 1 times 4x squared is the negative 4x squared. The negative times this would be like saying plus negative 3x is what I didn't show in here. So that would become positive 3x. And then opposite of negative 2 becomes positive 2 here. So our result will be 14x squared plus negative 4x squared gets you 10x squared. 30x plus positive 3x gets you 33x. And then 15 plus 2 is 17. Made another mistake. So it should be 17. So we end up getting 10x squared plus 33x plus 17. My coffee hasn't kicked in this morning, obviously. Okay, let's work. Here's our worked example. 7x minus 4x squared minus 9 plus 11 plus 14x squared minus 6x minus 7 minus 5x. In this example, we don't have any parentheses. So all I want you to do when you have this situation is we want to rewrite it as addition, all addition signs. So we're going to change all the subtraction to add the opposite sign. Okay? So we're going to take that 7x, and it's going to become plus negative 4x squared plus negative 9 plus 11 plus 14x squared plus negative 6x plus 7, and then, or it's just play plus negative 7 plus negative 5x. Okay, so now what I want you to do is I want you to take this and combine like terms and rewrite it in standard form. Do you see how we changed our subtraction problem into an addition problem? So now it's just like what we were doing before. So we changed it to addition, and so combine like terms and write it in standard form for me. So negative 4x squared plus the 14x squared got us positive 10x squared. The 7x plus negative 6x plus the negative 5x got us negative 4x. And then negative 9 plus 11 plus the negative 7 became negative 5. So our answer is 10x squared minus 4x minus 5, or you can write it as 10x squared plus negative 4x plus negative 5. Either way is acceptable. Here's our next worked example. We have 3x plus 4x squared plus 9 minus negative 14x squared plus 6x minus 7. Why don't you try to remove the parentheses first here by distributing negative 1 for this second set of parentheses. The first set of parentheses, you just distribute 1 to remove them. See what you can do. So now we have 3x plus 4x squared plus 9. So we just distributed 1 there, so nothing changed. Just remove the parentheses. But look at this. Now we have plus 14x squared minus 6x plus 7. So we distributed negative 1, or you can just say you add the opposite of each each sign is what we did there. We add the opposite. Now what I'd like you to try is to rewrite all those as addition, all the subtraction. So there's only one term here that has a subtraction sign. Can you rewrite this with a positive or adding instead of subtracting? So now we have 3x plus 4x squared plus 9 plus 14x squared plus negative 6x plus 7. Now we are set up to combine like terms and rewrite it in standard form. Why don't you give it a try? So 4x squared plus 14x squared gets us 18x squared. 3x plus negative 6x gets us the negative 3x, and the 9 plus the 7 gets you the 16. You could also write this as 18x squared plus negative 3x plus 16 would be acceptable as well. In this case, our lead coefficient is 18. Our degree is 2. Today I've been kind of helping you out. I've color-coded all the like terms. Obviously, when you're doing this on a test or a check for understanding, it's not going to be color-coded for you, but I want you just to see the like terms over and over and over again today to kind of drive home that point. Here's your first step here. I would like you to rewrite this expression using all addition signs. In other words, remove all the subtraction signs with addition. So now we have 13x squared plus 8x plus negative 2 plus negative 6x squared plus negative 1x plus 7 plus 8x plus negative 11. So now we have an addition problem. We've turned our subtraction into addition. Now I'd like you to combine your like terms and rewrite it in standard form. So 13x squared plus negative 6x squared should have got 7x squared. 8x plus negative 1x plus 8x is 15x. And then negative 2 plus negative 11 is negative 13. So you have to be pretty good with your integers. Most mistakes students make are just with your integer operations. You are allowed to use a calculator in this class. If you're not real strong with your integers, you may use a calculator as you go through the process. Just remember on your calculator, if you're adding a negative, you got to put in parentheses with the negative sign. All right, you could have also written this as 7x squared plus 15x plus negative 13. Bonus question for you now. Is this polynomial in standard form? Well, it is in standard form. I should have said, is it a monomial, binomial, or trinomial? I hope you told me trinomial because it has 3 different terms: the x squared term, the x to the first degree term, and the x to the 0 degree term, which is the 13 or the negative 13 times x to the 0 power. Let's go next level now with parentheses. So we have parentheses. Our polynomial is 9x squared minus 8x plus 1, a subtraction sign, and our parentheses, and our next polynomial, which is 5x squared plus 6x minus 14. I want you to rewrite the expression, removing the parentheses. So when we rewrote it without the parentheses, the first trinomial, all the signs stayed the same. It's 9x squared minus 8x plus 1. And then our signs change for the next polynomial. So it becomes minus 5x squared minus 6x plus 14. Now what I'd like to do is rewrite the expression using all addition signs. Remove the subtraction signs, make everything addition. So now we have 9x squared plus negative 8x plus 1 plus negative 5x squared plus negative 6x plus 14. Combine like terms now and rewrite it in standard form. Okay, as we combine like terms, 9x squared plus negative 5x squared gives us 4x squared. Negative 8x plus negative 6x gives us negative 14x, or we say minus 14x. And then 1 plus the 14 gives us 15, so we can say plus 15. It would be acceptable to say 4x squared plus negative 14x plus 15 as well. Bonus question now for you. What is the degree of this polynomial? This is a second degree polynomial. Again, we get that from the highest exponent value, which in this case is the 2, x to the second power. Okay, next example. Next one I'd like you to try here. Ooh, a little bit more challenging. I would like you to remove the parentheses here. Be careful. Right here, you got a negative 2 in front of the parentheses. Here you have subtraction sign. How do you handle this? All right, I'm hoping you got 24x squared, because negative 2 times negative 12x squared is positive 24x squared. Negative 2 times 3x is going to be minus 6x, or you'd say plus negative 6x. And then negative 2 times negative 5 is positive, or plus 10. Now, this side, we're just going to distribute the negative 1, or we're going to say add the opposite. So it becomes minus 4x squared plus 2x minus 6. Do you see how each sign went to the opposite sign here when we distribute the negative 1? Okay, now I would like you to rewrite the expression using all addition signs. So let's get rid of the subtraction signs I have in there and rewrite it with addition. We get 24x squared plus negative 6x plus 10 plus negative 4x squared plus 2x plus negative 6. Now we have an addition problem. Let's combine like terms and rewrite it in standard form. So 24x squared plus negative 4x squared gets us 20x squared. Negative 6x plus 2x gets us negative 4x. And 10 plus negative 6 gives us positive 4. So we get 20x squared minus 4x plus 4. You may have also said 20x squared plus negative 4x plus 4. Our bonus question to wrap it up here is, what is the lead coefficient for this polynomial? The lead coefficient is 20. It's the number being multiplied by the x squared. Again, the highest power, the coefficient of the highest power is what the lead coefficient is. So when we write in standard form, we know it's always the first coefficient there that we see, which in this case is 20. All right, all I need you to do now, if you haven't already, is copy down your goal notes. And then tomorrow's lesson, we will be multiplying polynomials, and we will be factoring using what's called greatest common factor. And then on Thursday, I want you to make sure you're signed up for Khan Academy. It looks like a lot of you have signed up now, but a few of you still haven't done that yet. So sign up for Khan Academy, because I'm planning on giving you practice with the polynomials on Khan Academy this Thursday. Have a great day, evening, or night.